Okay, so in this video, I'm going to talk to you about how do you objectively measure the performance of your workflows. And if your workflow is not giving you the desired output, like how do you change things and how do you measure their performance so that you can get more consistent, predictable, and reliable outputs from your workflow. Now, this lesson is largely going to be theoretical, so I'm going to try and keep it as short as possible because I myself don't always like theoretical examples. And in the next couple of lessons, we will learn more practically how do we actually implement this and check it out. So, but just to give you a high level theoretical understanding, that's what this lesson is going to be about. So you can feel free to skim through this, just get a high level understanding, watch it on 2x, even if you would like. And once you have like a conceptual high level understanding of it, you can always dig deeper by doing your own research on Claude, Google, GPT, etc. So usually what happens is when we are tweaking things with our AI, our prompts, our chat model, different variables as such, what we are trying to eventually get to is like one workflow or one process that produces the most consistent outputs, like the highest quality outputs, and also at the lowest cost. Right. So then we may decide like, does using a higher reasoning model actually matter here? Like, do I need to use, say, Claude 4 or 4.5? Or can I just use the Claude Haiku model? Or can I use, like, say, GPT's 3.5 Turbo or one of the like less reasoning models, which are faster? So, like, is there a trade-off to be had here, right? Because you can save costs if you use, say, one of these faster, cheaper models based on whether the task at hand requires a more advanced reasoning model or not. So, like, how do you test the performance of making these tweaks at different stages in your workflows? Right. And so that's what this process is about. So we want to objectively get to see if our workflow is performing better when we change different variables inside it. And so what the biggest problem actually is that AI functions like a black box, right? Unlike code, which behaves predictably all the time, like if you give it the same inputs, it's always going to give you the same outputs. But with AI and automations, it's not necessarily always the same. And so what ends up happening is even if we gave it the same input every single time, it's still going to give you a different output every single time. It may be similar, but it's not going to be identical because LLMs at the end of the day are prediction engines. They are probability based. So if you toss a coin 10 times, you may get heads or tails. Like the probability of getting heads or tails is 50-50. But is it going to be the exact sequence? Like, are you going to get five heads and five tails every single time? No. Are you going to get head, tail, head, tail, head, tail, head, tail, head, tail every single time? No. The patterns are going to keep changing because that's how prediction models work. So same with your chat model. When you are training it, like what examples you may give it may influence the output. What prompt you give it may change the output. And even if you give it the same model and same prompt, you may still get different outputs, right? Then you may tweak the temperature of each model when you are working with it. Like there's always context sensitivity, like how much of the previous chat does your model have as a reference. So like there are a lot of variables to test when you are working with AIs and LLMs and your workflows. And like even for simple workflows that may have 3 to 4 nodes, it can start to get complicated quite easily. The bigger your workflows, which may have 8, 10, 15, 20, or even like one big workflow with sub workflows, you start to see like how complicated this can get when you actually need to test out all these variables. So what we want to actually do is isolate variables and then test them. So you change one thing at a time, not three things, not two things, not five things. You change one thing at a time to be able to determine like, does this one thing actually affect my output or not? And we will show you in the next couple of lessons, like how do you objectively measure, has it changed my output? Is it performing better or is it performing worse? And it gives it a quantifiable score basically, so that you know if the change you've made is actually like a determining change or not. So what you want to do is you start with an hypothesis, right? Like you may say, I don't think having a high reasoning model in, say, data extraction matters so much. So instead of using, say, a Claude 4.5 model, you use, say, a GPT 3.5 Turbo or some cheaper model. And that may be your hypothesis. And you may see that there's no quality change in the output, right? So rather than spending more money on Claude 4.5 as an advanced reasoning model, you can save money and use a cheaper reasoning model. So the metrics you want to compare, and these are just theoretical, but like we will look at these in examples later, are basically accuracy and correctness. This is especially when you're doing any kind of classification or labeling of data. You can also do like semantic similarity, which basically says like, is the meaning of this kind of similar? You also want to check like efficiency and token consumption, like we were just talking about, right? Like if you're using Claude 4.5, that's going to use a lot more input tokens as well as output tokens. Whereas a lesser model, like say a GPT 3.5 Turbo, may use lesser input tokens and lesser output tokens. So therefore you get to save cost. Then another thing you want to check is like, are your AI models or your workflows hallucinating often? Are they producing bad outputs? Like how often are they producing bad outputs? And how do you compare and check like good outputs? So then you want to check like, are they performing reliably? How often do your workflows error? And how long, like this is a more advanced concept, but like how long are your workflows active, or like what is the uptime? This is usually more in the context of when you talk about servers and stuff like that, but based on your workflows and applications, this may or may not be applicable. So what you want to be working towards, and this is a very important concept, is to do any kind of meaningful evaluation. It all starts with building a great data set. And so, what you want to work towards is having a data refining process that takes messy, unstructured data from different sources and makes it clean and organized so that you know, like, predictably what your output of this data refinement is going to be, and that is going to be the input that drives all of your workflows. So I know, again, like I'm aware of how theoretical that sounds, and this is me just giving you the theoretical background, like which I learned when I was doing machine learning, these more advanced models, about actually learning how to build them from scratch and understanding parameters and stuff like that. So I don't want to bore you with the details, but the big takeaway for you is you want to find a way to cleanly organize your data. That is something you have to do. And that is something that has now become very easy with like these AI LLMs, that even if you had messy, unstructured data, right? Say you had one PDF document and one Excel sheet and one email, and you have all these different data sources. What you can do is like dump that into one big string, okay? Like you just say use an edit fields node, you dump all of that text in there, or you just put all of that inside one query or chat message and give it to your AI agent, and just say, using this input, like we talked about in the structured output parser, right? You can use a structured output parser, or you can just tell the AI, using all of these different text inputs, I would like you to come up with a systematic data structure or JSON format or array of everything that I will need in a clean, organized data format, so that I have like clean data to use throughout the rest of my workflow. Again, like these, you will see the more you build these AI automations and workflows, like how they work. But whenever you're stuck, if you feel this is something you haven't completely understood, just send me a DM or post inside the Skool community, and someone from our team or me myself will come in and help you solve this problem, because this is a problem you learn more by doing rather than by like learning or reading about, because till you actually have the application, you won't really completely understand like what it means and how do I do it. So, yeah, the workflow structure, which we talked about previously, or if you haven't watched the error handling lesson, but basically we have different ways of handling errors. So, say if some parts of our data in our data pipeline are missing, or they are invalid, or they are incorrect, accordingly, we may handle them with using the continue on error, the error triggers to notify, and so on. Another like good practice when we're working with data is we always want to keep in mind our prompt engineering framework of clear, and we want to include like examples. We want to have context given, the length, like the type of output, the examples, the audience, and assigning a role to our LLM. Okay, so this lesson is already going longer than I expected. Like, I wanted it to be a quick 5 to 7 minute introduction, but yeah, I think it's almost 8 to 10 minutes. So I will quickly skim over the rest of this just so that you aren't bored. Like we covered, like great data is far more important than having a great model. So you want to have like systematic inputs or systematic cleaned input data. So the data quality really matters, and this we will look at in examples when we are looking at classifications, like how do we know that, say, this part of an image is, say, a dog or a cat, or the face of a dog or a face of a cat. So then we will also look at, like, I mean, these are called annotations, which basically draw boxes around objects and label them. And that's how the AI understands like what's going on inside this image, so to speak. And similarly, for text or spam detection, an example of an annotation may be labeling emails as spam or not spam. Similarly, for sentiment analysis, speech recognitions, you can read this entire text. Why annotations matter is because without annotations, AI has no idea like what it's supposed to learn. It's kind of like trying to study for a test with no textbook and no teacher, just a random information with no guidance. So if you have bad annotations, your AI gets confused. And in short, like, annotations are how you teach AI what's what. And this comes in the form of you labeling your data well, giving it clear examples, good examples, and bad examples, and then that's far more likely to produce more consistent outputs, right? Then you just want to make sure your data is clean, free from corrupted files, encoding errors, duplicates, and so on. When we talk about scale and coverage, this may not be the most applicable. It depends on the size of data you're working with. But in a lot of cases, we may be working with like a few tens to few hundreds of documents for most of our like applications, especially also if you are using this for AI automations for a specific business case. Like, obviously, if you are building, say, a SaaS that's actually going to be used by possibly like a bunch of people around the world, and you need it to be trained on like millions of data rows, then this might be a problem that you run into. Then it's a nice problem to have if you are building that level of assess. But like, without getting too ahead of ourselves, in a lot of cases, I think anywhere from a few tens of rows to a few hundreds of rows are more than sufficient to give your AI and LLM as examples when we are starting out. So diversity is basically about like, you want to make sure your data covers edge cases and isn't just catered to one type of label or one type of examples. Again, we'll cover this in the next lessons, but basically you want to have what's known as representative data. And yeah, a few common mistakes to avoid is evaluating on poorly annotated data, poorly labeled data, evaluating on static data sets which may become outdated and no longer relevant. So yeah, whether that's in finance, fashion, language, marketing, like, things may change. You don't want to be using, say, training data or irrelevant data that's like just not relevant in today's day and age. So one big thing to take away is that you want to evaluate on metrics that matter for personal or businesses. Like, you don't want to evaluate on vanity metrics, and knowing what the vanity metrics are to each business or use case comes from having domain knowledge or expertise. So that's where working with some sort of expert or some sort of professional in the field or someone who has experience becomes extremely valuable in this entire process. A big takeaway also is you just have to be okay with updating the model over time. Training data may change, new models may come out, the prompts may change, the data may change, the logic may change. But the advantage of doing this is like, you kind of fix it once and you get the benefits in every subsequent output, say for days, weeks, months, or years, based on like how robust it is. Years is unlikely, especially with the rate AI is moving, but like, it's a small price to pay for the kind of gains that AI and these workflows can give you. So yeah, maintenance, iteration, and improvement are crucial to the long-term success of your automations. And just remember, your biggest takeaway from this model should be that great data is far more important than having a great model. You cannot improve what you do not measure. before you get fancy with model architecture and hyperparameters, you should always just check your data and like audit it and make sure that it's clean. Seriously, yeah, it's boring, but if you spend a few hours doing it, the best AI researchers in the world spend a bunch of their time doing data quality, data sanitization, like cleaning data, rather than on tweaking the actual models themselves. So if you use bad data with a great model, you are still going to get bad results. But if you use great data with even an okay model, you're still going to get pretty good results. So the action step, or one thing to take away as well, is the next time you start a project, spend a whole day if you need, or as long as you need, just exploring data sets. Like, think about how are you going to structure your data so that everything is going to flow seamlessly downhill from here, right? It shouldn't be like some uphill battle of like wrestling with data, missing values, and all these things. And like, I tell you this because this is stuff that I had to deal with when I was first learning about AI models. And yeah, the difference in quality of output when you give like just simple examples, like even if you just stick to a clear framework that we previously discussed, like even if you just gave it clearer examples, better label data, it really makes a difference in the long run. So, yeah, you'll thank yourself later, or at least your workflow will. So, anyway, that was it for this video. Thank you so much for watching till the end. I will see you in the next one. Bye for now.